My name is Jack Christensen, and I've been doing software development professionally for about 20 years, longer than that for fun. And one of the things that's bugged me is, why is it hard? I don't think this is a controversial opinion. I've never been talking to a programmer and saying, the thing that I really hate most about my job is just too easy. It's boring, we never get to do anything new. But as it turns out, it's really hard. Getting stuff to run at all is sometimes really difficult. Getting it to work correctly is a lot harder yet. Getting it to be secure, even harder. And then when you're planning it out, well, how long is it going to take to build? All of these can be enormous challenges. But a lot of things are hard. Running a marathon is hard. Learning to play an instrument is hard. But they aren't too hard. They're just difficult things to do. So is software development too hard? So a few years ago, I was pairing with a friend of mine on just a normal Rails project. And at one point, we'd been working together for a few hours that day. He pulled me aside into the back and hey man, can you tone down the negativity? You're kind of, being a little bit of a downer. I'm like, yeah, sorry man, I didn't realize, but I just been kind of given a running commentary on why does this take an hour when it should take 5 minutes? And it's not like there was anything wrong with the code base. I mean, it was fine. It was too hard, and it was really making me frustrated. I try and live by this, at least as a programmer. If it's too hard, I'm doing it wrong. There's got to be an easier way. And maybe this should be better worded, something is wrong. Maybe I'm doing it wrong, maybe somebody else did it wrong, maybe just the whole system is wrong. But something needs to be fixed. So why is it hard, and what can we do about it? That's what this talk is about. Some parts are just legitimately difficult. There's intrinsic complexity that is just enormous. But a lot of the things that are hard and frustrating in software development shouldn't be. So we're going to take some time, go through a bunch of different reasons software development is difficult, and we're going to discuss why it's hard, what we can do, and what we can't do. In late 2005, DHH, David Heinemeier Hansson, obviously, published a video how to build a blog in 15 minutes. I had been doing PHP, I'd done some ASP.NET. I watched this video and I'm like, I am done with ASP and I'm done with PHP. This is the way it's going to be. Now, I was very early in my career, and luckily I was at a non-tech company who just you do the things we need. So great, I'm just going to rewrite everything in Rails, push it to production, and I did all that pre-1.0. And, it's better to ask, forgiveness than permission, as they say. But in this case, I didn't have to, because it was the right decision. It worked out. But it wasn't because I was really smart. I was a noob. But I got lucky. I made a guess and it worked. It was a good decision for me, and it was a good decision for the company. That app is actually still running today. It's been maintained all the way up to Rails 5.2. But I haven't always been so lucky. One of our previous lightning talks mentioned prototype.js. Yeah, I was there. I've done a lot of that. And wait, jQuery, I've got to learn something new now? And how about, CoffeeScript? That was really cool for a while. But knowing CoffeeScript doesn't really benefit your career too much today. How many more of those are there along the way? Should I learn Backbone? Well, again, it's useful for a time, but you've probably migrated off that. Go a little closer today. Okay, we want a rich front end. Remember, what was it? Angular, Ember, Knockout, React. Today, is it React or Vue? Or maybe you're really on the cutting edge and you want to go to Svelte or something like that. But we just don't know. It's really just a guess often, and it makes a big difference to how difficult it is in the future. If you bet wrong, things go poorly. What's another reason it's hard? This is similar, but instead of just technical issues, it's changing business requirements. I've rarely been in a code base where I felt boy, the people who did this prior to me, they just didn't know what they were doing. Pretty much everybody with a few exceptions, pretty much everybody is competent. They do a good job, they work hard, they do their best. But if you have a code base where the business said originally do this, and over the course of several years, the business is now doing the exact opposite. And how many times has there been a feature that like, well, we could refactor the thing in 2 weeks, or we could put, a couple dozen if statements in there in 2 days and get it out the door. That happens all the time. And then you end up with, legacy. That's another reason it's hard. We're always designing something we've never seen before. Software is cheap. It's free to copy. If you write it once, you never write it again. So basically, by definition, we're always doing something we don't know how to do. We've never done it before. The upside of that is it's not boring. But where it can be frustrating is when it's just different enough that we have to rebuild it, but it's close enough to what we've done before that it's like, why is this hard? Why do I have to do kind of the same thing again? And I don't have answers to most of those questions, because I'm going to confess something here. I don't know what I'm doing. But we don't know what we're doing. Software development is a very new field. If you want to talk to people about architecture or painting or music, or physicians, people have been doing that for a very long time. Software development, generously, you would say it's about 70 years old. Its living memory is the entire history of the field. And as some evidence of that, we don't know what we're doing. You remember anybody back in the 90s how important object-oriented, everything was? You hear much about that today? It's still important in Ruby, but in Ruby, at least we've gone to, well, you really should use composition. You shouldn't use inheritance. Or how about monoliths and microservices? 5-6 years ago, if you mentioned you have a Rails monolith, your next statement is probably going to be an apology and discussing how you're going to refactor it to microservices. Whereas today, we've kind of come to the conclusion microservices are the solution for certain problems, but they're not just always do that. If you have that problem, use it. If you don't have that problem, don't use it. Or what about, the further step down the microservices path? Those things we just changed our mind once. Past microservices, you have Lambda functions. Now, anybody remember the 90s? Anybody remember, CGI bin? Standalone PHP scripts? I'm hardly the first person to point it out, but Lambda functions look an awful lot like what we did 25 years ago. So it used to be, you should do a standalone script. Then it's, you don't want to do that, you should have an app server. Now it's like, oh, you should do a standalone script again. Now, I know it's a little different now and so on, and it's a little better, but the point remains, we used to say one thing, then we said another, then we went back. Now, maybe you're thinking, some of these examples, they're just fads. If you had been paying attention, you wouldn't have jumped on the bandwagon. And we do have some principles that have stood the test of time. But how good are we at actually applying them? For example, separation of concerns. Is there anybody here who thinks separation of concerns is a bad idea? So all in favor of separation of concerns? Yay? I agree. How good are we at it? So again, think back to the 90s and the 2000s. What are we supposed to do with our HTML? Well, you put your content there. You put your CSS, that's where your appearance, your styling goes. And then you have JavaScript as well, and that's where your behavior goes. You certainly don't mix those up. You're not going to actually put your styles in a style attribute, and you're not going to use on-click and just throw some JavaScript in there. We're experts, we're professionals. We don't do things like that. Do you remember CSS Zen Garden? I actually looked that up the other day. That's still there. It's a single HTML file and hundreds of different CSS files that totally change how it looks. It was kind of the ideal of this is what CSS and the web is supposed to be. That was then. So this is a React conference, right? So everybody gets JSX, which purposely mingles your HTML and your JavaScript. And what's another one of the new trends? Anybody heard utility CSS? Tailwinds. So then we mix our styling in there too. So we're purposely mingling all three of those things that previously we said we shouldn't do. Now, I'm not saying that this is better or that this is worse. I'm just saying the right way, the best practice, has drastically changed. I say from that, it's hard to say we know what we're doing when we keep saying one thing and a few years later we say the exact opposite. So what's another tough thing that we have to deal with? Irrelevant decisions. So how should I organize my project? Where should I put my files? What build tools should I use? What language even? And then how about code formatting? It's not like programmers have ever argued about, tabs or spaces or anything silly like that. There are multiple domains where there are many potential solutions that are all fine. I know I've personally spent hours debating the fine points of should you use plural database names for tables or singular. Does it really matter? No. That's one of the big advantages of Rails. It drastically narrows the decision space because it just says this is the way it's going to be. Similar advantages with languages like Go, where you have the Go funct formatter. So tabs or spaces, you don't worry about that. Where do you put your braces? You don't worry about that. The formatter decides everything. So that's good. The flip side of that coin, though, is sometimes you have wrong decisions made for you. If you're trying to build something that doesn't fit the Rails way and you're using Rails, that's not fun. Now, some of those are just a general case of this problem as well. We have pretty difficult to use tooling. Anybody actually tried to set up like a JavaScript build chain from scratch? You have a lot to learn just to figure out what are you even going to use? It's like, oh, you're going to use Grunt or Gulp or, Webpack or, Babel is going to go in there somewhere. It's like just building this stuff, just figuring out what to build, to say nothing of actually wiring it together, is tough. And that's really frustrating when it's just like, I just want to compile this SAS file and have it happen automatically. Should I just use the SAS compiler standalone or should I wire it into my Webpack, system? Or maybe you just give up and then use the Rails built-in Webpacker stuff. Or you use create React app. Of course, when then something breaks or you need to make a change that doesn't quite fit in with those helpers, now you have two problems. Along the lines of tooling, if you're going to add a view to a Rails app, how many things do you need to do? Well, you need to touch the routes, you need to touch the controller, you need to touch the view, minimum. But you probably are going to need, if it's a new feature, you're probably going to need to touch the models, probably going to need to do a little bit of JavaScript, maybe a little bit of CSS, and we're good developers, right? So we're going to write tests. So for this one logical task, we have to go to at least 7 types of places, to say nothing of how many changes we need to make in each one. Now, I'm not sure who's responsible for that. Maybe it should be a better language. Maybe it's a problem with the framework. Maybe we need some sort of magical IDE. But wherever the problem is, it is a problem to have to change context so many times. That brings us back to that JSX example. That's one of the reasons JSX is nice to use, because it puts more stuff in one spot. Your logical task is happening in a single place. Here's another example. And it's really just another case for that same thing. Our organizational systems in software development are limited generally to a single dimension. So this thing on bottom here, class dog, cat, cow, if you learned OO stuff, you probably saw something like this in your textbook. We have different implementations of speak for each type of animal. That's the right way to do it because we use OO. The one on top, procedural, we certainly wouldn't want to use a switch statement. And Ruby, we're going to be idiomatic. So yes, I'll just say this up front, we would use the bottom one in Ruby. But for getting idiomatic, which of these is actually easier to modify? Well, that's not an answerable question, actually, without also knowing what type of modification are you going to make. So if I wanted to add a new verb, walk, well, it'd be easier to just do a procedure on top, def walk, have a case statement. I only had to change one spot. On the classical side, I have to change 3 spots. So in other words, if I add a verb, it's easier procedurally. But let's say I wanted to add class elephant. Well, now it's easier on the noun side because no matter how many verbs I have, adding the noun takes place in 1 spot. What changes you make together should be, the changes you need to make for a task should be in 1 spot, but we can only optimize for a single dimension. Another variant of this is just we have fundamental problems as we're working that are hard to fix. So I was doing a Rails thing a couple weeks ago, and I was calling from one website to another, and it's like, okay, I get the error in the JavaScript debugger console. It's like, okay, CORS header, that's what I need. So Google, like, what is the magic incantation to say, yes, just allow this request through? Great, it's a one-liner. So I put that header in that one action. And of course, I'm a good developer, so I'm going to run my tests even when I made such a tiny change. And all sorts of tests fail. Like, okay, wait a second. I just added a header. This can't be breaking anything. So I comment the code out, rerun the tests. They're still broken. Okay. I wonder, what sort of person would have pushed this stuff to master without running the tests? Well, I was the last one to touch this thing, and I wouldn't do something like that. Would I? I don't think so. All right, let me look at the last commit. Well, there was a lot there. Maybe I forget. Okay, so let me check that one out. Run the tests. It all succeeds. Okay, so I'm back one, so I guess I'm at fault. I made a mistake. Let me go back to master, run the tests. They all succeed. Okay. Put my line of code back that originally broke it. It still all works. Okay, so at this point, if you've been doing Rails a long while, you know what happened. But if you haven't, let's just go back and talk about the fundamental problem that led to an incredible amount of complexity that led to that weird error. So the fundamental problem is Ruby is really slow. And it'd be nice if when we're working in Rails, wouldn't it be convenient if when we make a change in a view, say, we can just go to the web browser, reload it, and it'll happen automatically. We'll be able to see the changes. Now, the simplest way to do that would be you have a file watcher. Whenever anything changes, it quits the Rails server and restarts it. That would be the simple way. You could hook that up in a couple lines of shell, you'd be done. However, Ruby is slow, so we can't do that. But it's still a problem. So how do we solve that? Well, we could solve it maybe by adding some lazy loading. That gets our server to start a little quicker. But then we still have to start and stop the entire server. So, okay, it'd be nice if we didn't have to start and stop the entire server. So how about if we not just lazy loaded stuff, but we also kept watching the files and we unloaded them when they changed and then we reloaded them. That would help. Now it's a little bit faster. That's also pretty complicated. And it's still not fast enough. So what do we do next? Well, how about we add some sort of background process that always keeps a Rails instance running, and whenever we start a new server or we run our tests, it basically forks a copy of that process and starts from there. That would be Spring. Spring got confused somehow, and in the course of checking out the commits and going back and forth, it noticed, oh, something changed. Let me restart this thing. Now, to be honest, that only cost me like 10 minutes. But that type complexity is pretty insane. And if you haven't seen that before, what would a new developer think there if they didn't even, you wouldn't even know Spring is a thing when you're first starting in Rails. The complexity there is very high when you're trying to fix a fundamental problem at a higher level. So here's another problem. This is where we actually shoot ourselves in the foot a lot. So we like new stuff. Now, some of this can be resume-driven development. That's really our own fault. When you have a basic CRUD app, but somehow it ends up needing, some big data with machine learning operating on it. And of course, you're going to access it via some Lambda functions. That's our fault. But to be more charitable, I don't think that's really the problem most of the time. Partly we're drawn to new stuff just because we like to learn. But I think a lot of the times we're drawn to new stuff because we're just trying to escape. It's a Rails conference. A lot of people here have dealt with large Rails applications. And if there's one thing about large Rails applications, it sure is easy to change things, right? I want to rename this thing, refactor this class. Yeah, that's not going to break a thing. Yeah. No. So if you've been fighting with a Rails app for like years, and you get to the point where it's like, man, I really don't want to make any changes here, you might really be inclined to try something with, say, static typing next time you start a new project. Well, you're going to have a whole new set of problems. So at this point, you probably all agree with my pair. It's like, good grief, man, stop with the negativity. And you're right. I mean, for all that, I think software development is about the most fun thing in the world. I'd want to build software even if I couldn't do it as a job. But because it's so fun, it's something I'm so engaged with, when you run into issues, it's so frustrating. So let's move on. Let's start with first, there are a few good things about it being hard. And then we'll move on to the real meat of the matter, which is what we can do about it. So why is hard good? So 120 years ago, a few bicycle makers were at the forefront of the aeronautics industry. In fact, you might say they invented it. Anybody know any bicycle makers or people in their garage that are actually at the forefront of aeronautic engineering today? It doesn't really happen. But we can still make an impact. This is a super young industry. It's a super young field. Many of the pioneers, when you look up such and such, algorithm, like RSA, well, those people are still alive. They're still doing things. The pioneers are still alive and practicing. Those that have passed on, they're still in living memory. We might not be perfectly on the ground floor, but we're only a step or two away from it. So just from an intellectual pursuit, point of view, we can still make a difference. From a selfish point of view, we make more money because it's hard. So that's something I try and keep in mind when I get really frustrated at the end of the day, like, wait a second, it's a good job. So just deal with it, just deal with it. And that's kind of the way you can look at it as an employee. If you're more entrepreneurial minded, solving hard problems is profitable. Does anybody remember trying to deploy Rails apps, before Heroku? It was pretty terrible. Heroku built a great business out of solving a hard problem. We run into hard problems every day, which means we run into opportunities every day. So we've talked about some of the reasons software development is hard. We've talked about the reasons that it can be good. Now let's get into what we can do about it. So the one problem we really can deal with, we can try to deal with, is what's coming next. But it's really hard. It's really, really complicated. And by that, I mean it's complicated. Complexity is the problem. Software development is enormously complicated. And complexity is the enemy of correctness. There's a statement I heard or read years ago, can't remember where it came from, but it was saying there's a big difference between there being no obvious bugs and there obviously being no bugs. Complex software usually has no obvious bugs. This is not a new idea. The competent programmer is fully aware of the strictly limited size of his own skull. This is from Edgar Dijkstra, 1972. So before most of the people in this room were born, they were already saying that. So here's a definition of complexity. How many things impact the operation of the system in question? Or, a little more down to earth, how big does my skull have to be to understand this thing? Now, sometimes it's a simple definition, but sometimes it's still hard to quantify. You know, some number of things, it's not like everything has the same cognitive overhead. So let's talk about a few things that we might want to minimize. So how about infrastructure? So if you had to develop for a system or deploy or maintain, would you rather have 2 Postgres databases, 2 Mongo databases, or one of each? 2 Postgres. 2 Postgres is definitely the right answer. You know, reasonable people may disagree, but reasonable people have been wrong. But I think everyone would agree one of each is the worst scenario. What are other types of infrastructure we want to minimize? Well, databases obviously, but programming languages. How many languages do you need to know just to do a common web app nowadays? You know, it's like, well, you need something on the server side, you need SQL, you need HTML, you need CSS, you know, you're going to need JavaScript, but maybe you don't like JavaScript, so maybe you'll use Elm, or maybe you'll use TypeScript, or, you know, back in the day you'd use CoffeeScript or whatever. You know, even if you're trying to minimize it, you still have to deal with half a dozen languages. And then if you find something like, oh, I know we're using Ruby, but I'd rather use, you know, Go, or whatever stack you like, I have my preference here, so now we just add one more. You know, libraries, the same thing. Build tools, you know, in JavaScript, that's fun. You know, deployment tools, you know, that type stuff, you know, keeps on changing. You know, anybody used to use like Capistrano or something? I mean, Capistrano, and then we have Mina, and then, you know, okay, well now maybe it's Ansible, or maybe you're just putting stuff in Docker containers, or maybe you just sidestepped it all and you pushed to Heroku. But there's a lot of different kinds of overhead there. So what's another thing that adds to complexity? Leaky abstractions. We should minimize them. So on top we have there an active record query, and on bottom we have the actual SQL query. Active record is really convenient, and especially if you do something more complicated, like you have named scopes. But it never really totally hides the SQL. If you're going to be really good at using active record, you really have to be really good at SQL. What does that mean? You now need to know 2 things instead of 1 thing. Now, I'm not saying you shouldn't use active record. It has its advantages. But when you're thinking about what is the cognitive overhead, what is the complexity cost for making decisions, well, this is something to think about. If you add a new abstraction, you now have 2 things to know about. Or if you add a new leaky abstraction. But all abstractions leak if under enough pressure. I put almost there just to cover myself because I try to avoid using absolutes in general. But I actually can't think of any abstractions that don't leak. Even things that we generally don't think about, like a file system. Within the last couple of years, Postgres had a data loss bug related to the idiosyncrasies of fsync across different file systems and thinly documented, you know, kernel, you know, stuff. Now, the bug's been patched, and the kernel devs and the Postgres devs are trying to work on like what's the best solution for this. But that's actually a really hard problem, and your file system does leak. You know, especially try using NFS. See what happens there. Run your database over NFS. That sounds fun. What's another one that leaks? How about the processor cache? So I saw a really good talk a couple years ago. It was either at RubyConf or might have been at ACR. I'm not sure which. But the speaker showed an example of having a class that had a small number of instance variables, another one with a larger number of instance variables. And he showed the example of how long it took to access the various instance variables. And one was a lot faster than the other. And what it boiled down to was the cache line size of the processor. Like, wow, I'm in Ruby. This is high-level stuff. Why does that even show up? But it does. How about speculative execution? This is a really interesting one because the processor presents us the abstraction that it executes serially. And in a sense, that abstraction is perfect. You know, it actually executes out of order. It goes down branches before it even knows which way to go, and if it guessed wrong, it backs up and makes it so it never happened. The abstraction is perfect, except that it leaks some information via timing if you record how long it takes. This is Spectre and Meltdown, which I'm sure you've all heard in the news over the last couple of years. So what do we do about it? Prefer too little abstraction to the wrong abstraction. Both are bad, but if we're going to make a mistake, less abstraction is the better mistake. Generally try and use the rule of threes when deciding if I'm going to extract something. First time I see something and say, oh, I see the pattern there. Don't do it. Second time, make a note of this. Third time, actually pull the thing out. So let's talk more about abstractions, because I think it's a really important thing that what is their cost. So this is some Ruby here, and we're going to iterate over list, which given list is an array, and we're just going to call a method on it. So this is, pretty much 101 level stuff. You'd probably get to this in your first few days, couple weeks of programming. What do we need to know to understand this? You need to understand variables, assigning to a variable, you need arrays, array indexes, method calls, Boolean expressions, and we need to know that a while repeats while the expression is true. It's a lot of things, but it's all beginner level stuff. But that's not how we would do it in Ruby, is it? Well, what's the next level of abstraction? Well, traditionally, the next one would be a for loop. But Ruby's for loop is just syntactic sugar on each. So we'll jump to JavaScript here just to look at a traditional for loop. What's new here? What additionally do we have to understand? Well, new keyword, it handles the loop counter for us. It's basically shorthand, not too much. But that's not what we'd do in Ruby, is it? We would actually use each. So this is getting more idiomatic here. What do we need to know here? What additional do we need to know here? The entire concept of blocks, which that's just a single sentence, but there is a lot in that single sentence. And I presume everybody here, it's a Ruby conference, I'm not going to go into what that means. You all know, there's a lot. So each method yields elements to the block, which again goes into we need to know what a block is. Now we need to know there's a method called each on array. But that's not actually what we would write today either. There's one more step. So we would actually write this, each with symbol to proc. Now what do we additionally, in addition to all the other things we need to understand, what additionally do we need to understand? Well, what is that weird thing with the colon? So symbols, entirely new concept. What is that pretzel thingy? If you're from Sealand, you probably say, what, address of colon? What in the world? Is this a function pointer or something? So you need to know that, oh, this is an operator that converts between procs and blocks. But it also will use toProc if you don't have if there's not like a native conversion there. Okay, so this will actually call toProc on this symbol thing. Well, what does that do? Well, symbol defines this toProc such that the proc that's returned will accept an argument and call the method named by that symbol on that argument. Which, okay, that implies metaprogramming. So that means that call is either going to be send or it's going to be eval. So to understand this one line of code, there is a much greater overhead of what we need to understand. Now, I'm not recommending against this style. I mean, don't use while loops in Ruby. But I'm just pointing out, with every level of abstraction that we add to make our life easier, we also greatly increase the cognitive load that we have to bear to get there. So that brings up this idea of foreground and background complexity. Background complexity makes the system less accessible to newcomers. But generally, you have to pay that cost once. Foreground complexity is paid all the time. This brings up another point. So number of types versus number of things. Everything we've discussed so far is actually an example of that as far as complexity goes. Adding a new type of thing is expensive. We talked about that with Postgres and Mongo. It's easy to add another of the same kind. Adding a new kind is expensive. But if we add a new kind of thing, sometimes we can reduce the overall number of things. The equivalent behavior in active record is usually shorter than the SQL statement. The each with symbol to proc is far shorter. And it's not just shorter, the foreground complexity is less. There's a lot of other examples like Sinatra versus Rails. They'd make different trade-offs there. Go and Rust. Go is less less background complexity, more foreground complexity. Less abstraction abilities. So minimizing complexity is the goal, but often we're trading one type of complexity for another. Another example, how do we want to do numbers? Well, we could use binary or we could use hex. In one, the vocabulary size is 2, and another, the vocabulary size is 16. Vocabulary is the background complexity. The number of digits is the foreground complexity. It's a balancing act. We usually don't want to use base 2, but I've never heard of anybody using, base 512. So that's one aspect of it. The other aspect of it is coupling. That's the other thing that leads to complexity. Whenever you want to change one thing, but to change A, you also have to change B, there's a problem with coupling. And unfortunately, our favorite language is very susceptible to that. So in the grand category of languages, what would we say Ruby is? It's a scripting language, a colloquial way of putting it. What's another way people refer to as scripting languages? Glue languages. So what do you do with glue? You couple things together. So by its very nature, what Ruby is good at is actually what we want to avoid in large-scale software development. Rails is similar, though a little different. It appears to rely on coupling for a lot of its magic. The fact that Active Record and the form helpers and Action View and the controllers, they all seem to work together. That in actuality, there actually are abstract interfaces. You can do things like active model. But in practice, when you've got a form that needs one little bit of behavior, oftentimes it's easier just to add a new method to the model rather than to actually make the form object like you should. So Rails makes some of these things tough. So what can we do about it? So modularity and isolation. We divide and conquer. So we have to remember our skulls are really small and the problem is big. So anything we can do to make one part of the problem small enough to fit in our skull is going to improve the code. Modules can be anything. They can be a function. They could be an entire application. Maybe extracting a microservice really is the right way to modularize something. The best abstractions, the system doesn't need to know about. The rest of the system doesn't need to know about the abstraction. Some of the times, a small amount of background complexity is okay. But the worst part of it is if you extract something, as in you move it somewhere else, but you don't actually decouple it. Distributed monoliths are like literally the worst. So it takes a lot of conscious effort, especially in Ruby and Rails, to avoid coupling. But that's about the single biggest thing we can do when things are too hard. But back to the negative part, it's always going to be hard. So from this same paper from 1972, programming will remain difficult. Because once we have freed ourselves from the circumstantial cumbersomeness, we'll find ourselves free to tackle the problems that are now well beyond our programming capacity. So anytime we figure out something, we just tackle harder problems. Building a web app of the same functionality as 1997 is really easy today, relatively speaking. The same for like what we did with Rails 1.0. We're just tackling bigger problems. So it will always be hard. So in summary, there are a few things that we can't do much about. We can't see the future, and we're always doing something new. But as part of that, some of the problems are opportunities for us to discover new things. We don't know what we're doing. Well, somebody in here, their name might be on the next, algorithm or pattern. Difficulty can be a good thing sometimes. And lastly, what we can do about it, we minimize complexity by minimizing the types of things. We minimize our leaky abstractions, and we have to make careful trade-offs between background and foreground complexity. So I hope this talk gave you some helpful ideas to think about. Thanks for listening.